Finally, the treatment for sickle cell anemia is here, and this follows the FDA's approval of the Casgevy, which is a gene therapy technique. Of course, this will cost you much money, but what's always there is that when new methods are brought in, they're always expensive, but with time, the price falls down. So it will cost you much to get this treatment, but yeah, it's really helpful. So let's dive in and see how it works. First and foremost, we have to know the various types of hemoglobin. We have the normal hemoglobins and the abnormal hemoglobins. The first normal hemoglobin we have is the HbF, which is present in your fetal life, and it's regularly replaced by the HbA, which is the normal adult hemoglobin, and also we have the HbA2. Now, when we go to abnormal hemoglobin, we have the HbS, which is for sickle. Then we also have the HbC and also the HbE. So how is the HbS affected in this scenario? And by the way, this technique can also treat the thalassemia. I'm sure you know what thalassemia is. Okay, the Casgevy gene therapy technique employs the gene editing technique known as the CRISPR-CAS9, which in full is clustered regularly interspaced short palindromic repeats, CRISPR, and Cas9 is an enzyme. The first step into the procedure is stem cell collection. This can either be collected from the bone marrow or from the whole blood, which is commonly used nowadays. And after the sample is drawn, the next procedure is the gene editing technique. The CRISPR-Cas9 technique precisely targets a specific region in the BCL11A gene, and this gene is the one that is responsible for the suppression of the HbF, that is the fetal hemoglobin that is present during birth. So after birth, this gene suppresses the production of the HbF as it transitions it to the HbA, which is now the normal adult hemoglobin. Yeah. So by disrupting this region, the system will now start producing the HbF, the fetal hemoglobin, again. And do you think this is really important in this case? Let's continue going ahead and you'll realize it's important in this case. Also remember that this sample that is being edited is from the same patient. Yeah, we don't take sample from a different patient and then edit it to transfuse it to a different patient. No, it's your own sample. Yeah. So meanwhile, as all these are going on, the patient should undergo a chemotherapy to destroy the existing defected bone marrow to create space for the newly edited stem cell that will now aid in the production of the normal hemoglobin, including the HbF and now the HbA. Remember, we are getting the HbF because we've altered the BCL11A, which is a gene, and it's the one responsible for the suppression of the HbF post-birth as you now transition to the normal hemoglobin, the HbA. After editing, the stem cell is transplanted back into the patient, whereby it will now start producing healthy hemoglobins that will reduce the risk and severity of sickle cell anemia as well as thalassemia. So these all about this whole process. Yeah, and I'm trying to learn more about it. Yeah, in case of any new thing that I'll come across with regards to this, I'll be glad to share, but I'm sure it will be a costly one. Yeah, so let's keep waiting and see what comes up, and I'll continue sharing with you. Yep. Cheers. See you again in the next one. Don't miss. Okay, peace out.